Welcome back to Science in Sleeping. I am so glad you are here tonight, joining me once more on this gentle journey, a journey where science and serenity come together, a place where curiosity is welcomed but never demanded, and where knowledge is offered like a soft blanket, comforting and light. Tonight, we are drifting back in time, far, far back, to an Earth that looked very different from the world you know today. An Earth that was almost entirely covered in snow and ice. A time scientists call Snowball Earth, a chapter of history both strange and magnificent, a mystery that still invites debate, research, and wonder. But before we dive into frozen oceans and icy continents, let me speak to you, just you, the listener lying in your bed, resting, perhaps restless, perhaps already starting to feel your body soften into the mattress beneath you. You don't need to hold on to anything I say tonight. You don't need to take notes or remember facts, though you may remember a detail here and there, perhaps carried with you into your dreams. This is a space where learning and letting go can coexist. Think of this time as a gentle gift to yourself, a period where your mind can be entertained and comforted, while your body is invited to rest. If you drift off halfway through a sentence, that's perfectly okay. It means the story is doing its work, letting your brain feel safe enough to let go, to float into sleep. I'd love for you to take a moment now, just to notice where you are. Maybe you're watching or listening from your bedroom, the lights dimmed, the world around you quieter than it was during the busy day. Or maybe you are listening in another part of the world at a different hour. Some of you might be tuning in from cities where the night is alive, with faint traffic or glowing street lamps. Others may be surrounded by silence in the countryside, or under star-filled skies. Wherever you are, know that you are part of a quiet community of listeners right now. A group of people across the globe who are all here for the same reason: to relax, to rest, to learn in the gentlest way. It's a comforting thought, isn't it, that right now, somewhere else, another person is listening to, breathing slower, feeling their eyelids grow heavier. And as you listen, remember this: you do not need to try to stay awake. You do not need to try to hold every detail. You can drift in and out of attention, floating like a feather on a slow breeze. The story will keep going, with or without you, steady and soft. And if you return at another time, the story will always be here, waiting. So please, settle in, make yourself comfortable. Feel the mattress supporting you, the pillow cradling your head. Maybe take a deep breath, filling your lungs slowly, and then letting the air fall away, soft and easy. Another deep breath, if you like, and with it, a softening of your jaw, a loosening of your shoulders, a melting of the day's weight. Now, let us begin our story, a story of ice, of survival, of Earth itself wrapped in a white embrace. A time when oceans were frozen across their surfaces, when mountains gleamed with ice, when the very air was crisp and sharp. Tonight, we are traveling back hundreds of millions of years, to a planet almost unrecognizable, and yet, this frozen Earth still holds secrets that shaped the world, you know. The world you walk upon every day. This is the story of Snowball Earth. Have you ever wondered what our world might have looked like if the warmth we take for granted was taken away? If the sun still shone in the sky, but the Earth itself had wrapped in layers of snow and ice so deep that oceans froze over. Continents gleamed white, and life struggled at the very edges. It is hard to imagine, isn't it? This blue and green planet turned almost completely to white. A glittering sphere, adrift in space, yet scientists believe it happened. Not just once, but perhaps several times. Hundreds of millions of years ago. Picture yourself standing at the edge of such a world. The air is thin and sharp, colder than anything you have ever felt. A silence covers everything, a silence so vast that even your thoughts feel muffled beneath it. Snow stretches to the horizon. The sea beneath you is sealed by a sheet of ice thicker than any skyscraper is tall. The sun rises, but its warmth does not reach you. Its rays bouncing off the endless white surface, blinding yet powerless. This is not a fleeting winter, not a passing storm, but an earth locked in deep freeze. So how did such a thing come to be? How could a living, breathing planet, warmed by the sun, fall into a slumber so deep that glaciers covered the tropics? To answer this, we need to step into the world of deep time, a scale so vast it can make you feel wonderfully small. Imagine a clock not measuring hours, but millions of years, with each tick echoing across eras and eons. The story begins around 720 million years ago, in a time geologists call the Cryogenian period. The continents were arranged differently than they are today, broken apart and scattered in strange positions, many of them clustered near the equator, closer to the warmth of the sun. That sounds comforting, doesn't it? Continents basking in sunlight? Yet this arrangement set the stage for a catastrophe. Here's why. When land is near the equator, it is subject to intense rainfall and heat. This accelerates a process called weathering, the slow breaking down of rocks as rocks crumble. They trap and remove carbon dioxide from the air, and carbon dioxide is one of Earth's natural blankets, a greenhouse gas that holds warmth close to the surface. Without enough of it, the planet cools, bit by bit. Imagine pulling away a blanket on a chilly night. At first, you shiver slightly, then more, until finally your whole body feels the cold. That is what happened to Earth. The blanket of carbon dioxide thinned. The air cooled. Glaciers began to form. Ice reflects sunlight instead of absorbing it. So once ice began to spread, the cooling sped up. The more ice, the colder it became, a feedback loop of frost. Scientists think that within a few million years, ice had spread from the poles all the way to the equator. Oceans froze, perhaps hundreds of meters thick. Imagine the Indian Ocean or the Pacific sealed shut, white and silent. Beneath it, liquid water still moved. But in darkness, cut off from the sky, did you know that tiny bubbles of ancient air, trapped in ice cores, are part of how we know this? These bubbles are like time capsules, carrying whispers of atmosphere from long ago. They tell us about greenhouse gases, about temperature, about the breath of the Earth itself. And when scientists read those signals, they found fingerprints of extreme cold. It is astonishing to think life endured. Yet it did in the oceans beneath the ice. Microbial life clung on, feeding near volcanic vents. In patches where ice may have been thin, some sunlight still filtered through, supporting tiny algae. Life was reduced, but not extinguished. The resilience of life is a quiet miracle, a persistence even in the harshest times. But Earth is not static. Slowly, over millions of years, volcanic eruptions continued to pump carbon dioxide back into the air. With the oceans frozen, there was no easy way to remove it. The blanket grew thicker again. The planet warmed, bit by bit, until eventually the ice began to melt. And when it did, it melted catastrophically. Imagine millions of years of ice vanishing in a geological heartbeat, oceans roaring back, releasing floods that reshaped continents, a snowball melting into a world of rivers, storms, and warmth, and in that release came transformation. The sudden surge of nutrients from melting ice may have fertilized the oceans, fueling explosions of life. Some scientists believe that Snowball Earth may even have set the stage for the rise of more complex organisms, including the ancestors of animals. It is a beautiful thought, isn't it, that from the deepest freeze, from struggle and scarcity, came the foundations of abundance. There is a kind of poetry in this, that our planet can fall asleep so deeply, covered in snow and silence, and then awaken again, transformed, life, fragile yet enduring, carried through the long winter, waiting for the thaw. It makes you think of your own winters, the times when things feel frozen and still, when movement slows, yet within that pause, there may be seeds of renewal, unseen, waiting, perhaps. In this way, Snowball Earth is not just a scientific mystery, but a metaphor, a reminder that even the coldest seasons can lead to flowering, that life can endure long nights and long silences, emerging with new possibilities, that time itself carries both the frost and the thaw. And so, as we close this part of our journey, let the image settle in your mind. Earth, glittering white, silent and vast, a snow globe drifting in space, then, slowly, the first cracks forming, the first trickles of meltwater running, a world preparing to awaken as you drift deeper into rest. Know that our story continues, for Snowball Earth is only one chapter in the grand tale of our planet. In the next part, we will wander further into the evidence, the stones and sediments that still hold memory of that deep freeze, the signs that whisper across millions of years. But for now, allow yourself to float gently, knowing the world has endured great winters before, and always, eventually, found the warmth again. Have you ever wondered how we can possibly know what happened hundreds of millions of years ago? How could anyone look at the world today, with its cities, forests, and oceans, and confidently say that once, long ago, the entire planet was covered in ice? It sounds almost like myth, doesn't it? As if it were a story whispered by the earth itself. But science, quietly and patiently, has found ways to listen. Picture yourself walking along a quiet cliffside. The air is cool, the waves below lap gently at the rocks. The stone walls around you are striped in colors: red, gray, white, and black. They are not random patterns. They are pages in a book written not in ink, but in minerals and sediments, and just as you might trace your fingers along the lines of an old journal, scientists trace the layers of rock. Each layer is a memory, a frozen moment. The rocks tell us of ancient glaciers. They show grooves and scratches where ice once dragged across the land, carving its story. They show deposits of stones and pebbles dropped in places where only icebergs could have carried them. Imagine a lone rock resting deep in ancient mud, thousands of kilometers from its birthplace, carried there by ice, released as the iceberg melted. That single rock, out of place, is a quiet piece of evidence, a whisper saying, "I was here, I was carried by the cold." And then there are the cap carbonates, strange and beautiful layers of limestone that formed directly on top of glacial deposits. Picture this: after millions of years of ice, the earth warmed so suddenly that oceans roared back to life. Water, rich with carbon dioxide, fizzed like an uncorked soda, pouring minerals into the sea. These minerals settled into stone, creating smooth white layers above the rougher glacial rocks. It is as if the earth had signed its own name. Here ended the age of ice. Here began the thaw. But the rocks do not speak loudly. They require patience. They require imagination. Scientists, like detectives, piece together the faintest clues. They ask, why are these rocks here? Why do they look like this? Could anything else have left such a signature? And slowly, through evidence collected across continents, a picture emerges. Did you know that some of the most persuasive evidence for Snowball Earth is found in Africa, Australia, and Canada? These far-flung places share similar signatures, thick layers of glacial deposits lying in what used to be tropical zones. That is the surprising part. Ice near the poles makes sense, but ice at the equator that defies expectation. That is the fingerprint of a frozen planet. The suspense of this story lies in its gaps. Even now, scientists debate, was Earth truly a complete snowball, sealed entirely in ice, or was it with thin bands of open water near the equator? The evidence tilts strongly toward a full snowball, but there is room for wonder, and in that uncertainty, there is space for imagination, for questions that stretch your mind just enough before sleep. Now imagine yourself as one of the first geologists to stand before these rocks, the wind rushing past your ears, your hammer in hand, striking stone that has not spoken in hundreds of millions of years. The fragments fall, and inside you see something unexpected: glacial debris in what should have been a warm environment. It is as though you opened an old book and found a photograph from another world tucked between the pages. It makes you pause, doesn't it, to think that the earth carries its memories silently, waiting for us to notice, waiting for us to ask. Rocks that have lain quiet for eons suddenly reveal themselves. They tell us that the world has been many different things, not always the stable, familiar planet we think we know. There is also the magnetism locked in stone. Did you know that when certain rocks form, they preserve the orientation of Earth's magnetic field at that time? By studying this magnetism, scientists can tell where on the globe a rock was born. And when glacial rocks show they were formed near the equator, it deepens the mystery. For how can you have glaciers at the equator unless the entire planet was cold? It is humbling, isn't it, to realize that the ground beneath your feet is not just soil and stone, but a vast archive, a memory palace of the earth. Every mountain, every cliff, every canyon is a shelf stacked with chapters, some still unread. And so we find ourselves suspended between certainty and wonder. The evidence is strong, but the full picture is still incomplete. It is as though we are piecing together a puzzle with missing edges. And yet, even with gaps, the image of a frozen earth gleams through. Sharp and unforgettable, there is a poetry in this too. That the earth carries scars and signatures of its past, not unlike us. Each of us holds memories, some vivid, some faint, some hidden beneath the surface. They shape us, even if we are not always aware. The planet, in its way, is the same. It has endured extremes, carried them forward, and still continues on, alive and resilient. Perhaps this is why stories like Snowball Earth comfort us. They remind us that even the strangest, most difficult times can be survived. They remind us that beneath the silence, life persists, and when the thaw comes, it brings not just relief, but transformation. So let this thought settle with you now, as you drift deeper into rest. Imagine the earth itself as a storyteller, its voice slow and steady, its words written in cliffs and valleys, in stone and in ice. You are listening not just to me, but to the earth itself, whispering its ancient lullabies. And as one chapter closes, another begins. For if the rocks tell us that the earth froze and thawed, then the next question rises gently like a tide. What happened to life during this frozen age? How did fragile organisms survive? How did they endure millions of years without sunlight? That, dear listener, is where our story drifts next, into the secret survival of life beneath the ice. Have you ever wondered how fragile life can endure when the very world around it seems intent on silence? When oceans freeze, when sunlight is locked away, when food and warmth vanish almost entirely, how could anything survive, let alone thrive? Through millions of years of ice, this is the mystery of Snowball Earth, and it is one of the most astonishing survival stories ever told. Imagine yourself beneath the ice. The surface above you is a thick, unbroken ceiling, meters upon meters of frozen water. It blocks the warmth of the sun. It muffles sound. The world is dim. Only a faint blue glow trickling through in the rare places where the ice is thin. It feels as if you are standing beneath glass, beneath crystal, but this glass stretches across continents, endless, and yet even here, in the deepest cold, life did not vanish. It retreated, it adapted, it found pockets of refuge. Like a candle burning in a cave, small but steady, life endured. Scientists believe that volcanic vents on the seafloor may have been sanctuaries. Picture them, black chimneys spewing mineral-rich water, warmth seeping into the freezing ocean around them. Strange microbial communities flourished, feeding not on sunlight, but on the chemistry of the earth itself. It is a kind of alien ecosystem, thriving without the sun. A reminder that life is inventive, that it will use any tool available. Did you know that some modern microbes can live in boiling water, in acid, even in radiation? These organisms, called extremophiles, give us a glimpse of what early life may have been like. They are proof that life is far tougher than we often imagine. If microbes today can survive conditions that would kill us instantly, perhaps their ancient cousins could endure an earth of ice. But hydrothermal vents were not the only refuge. Scientists suspect that thin bands of open water may have existed near the equator. Picture narrow stretches of dark ocean. the only places where the surface was not sealed. Here, photosynthetic organisms, Steiny, algemite, have clung on, drawing what little light they could. These narrow oases would have been lifelines, fragile threads connecting survival to possibility. And then there are the cracks in the ice itself. Ice is not perfect. It fractures, it shifts, it lets small shafts of sunlight filter down. In these veins of light, algae and bacteria may have floated, photosynthesizing just enough to persist. It is almost poetic, life finding a way through the smallest cracks. Some scientists even think that life found refuge in pools of salty water trapped within the ice. Salt lowers the freezing point, allowing liquid brine to exist inside frozen shells. Imagine microscopic worlds hidden in tiny pockets of liquid, entire ecosystems in droplets, silent but alive. The suspense of this story lies in its fragility. For millions of years, life was pushed to its limits. The population of organisms must have been drastically reduced, bottlenecked to near extinction, and yet, that very pressure may have sparked innovation, for when life is forced to adapt, it sometimes discovers new strategies, new paths. Perhaps this is where the seeds of complexity began to stir. Some scientists argue that the harsh conditions of Snowball Earth set the stage for the rise of multicellular life. Before the freeze, life was simple, mostly single-celled organisms, but after, in the thaw, we begin to see signs of more complex forms, like the Ediacaran creatures, soft-bodied organisms that hint at the ancestors of animals. Could it be that the hardship of Snowball Earth prepared life for its next leap? Think of it like this: a forest fire destroys much, but it also clears space for new growth. The ice of Snowball Earth may have been devastating, but when it melted, it left behind oceans rich in nutrients, oceans ready to host an explosion of life. There is something strangely comforting in this, isn't there? That even in the darkest winters, life holds on, and not only holds on, but sometimes emerges stronger, more inventive, more ready for what comes next. Imagine drifting to sleep with that thought, that resilience is not loud, it is quiet. It is the persistence of microbes beneath ice, the stubbornness of algae in a crack of light, the determination of life to keep breathing, no matter how thin the air. It makes you reflect on your own life, doesn't it? On the moments where things feel frozen, where progress feels stopped, where light feels faint, and yet, even then, there may be quiet growth, unseen strength, persistence building beneath the surface, waiting for its time. So let us return to our frozen earth for just a moment longer. The oceans sealed, the continents silent, volcanoes glowing faintly in the dark, brine pools shimmering beneath ice, microbes drifting in tiny shafts of light. Fragile, enduring, life was not abundant. Not yet, but it was there, holding on with invisible threads. And then, after millions of years, the thaw came. Imagine the sound of ice cracking, the roar of floods, the sudden rush of warmth. What must it have been like for those tiny survivors? For the first algae to feel full sunlight again, for the first microbes to find oceans open and vast. It must have been like awakening after a long, cold sleep. The resilience of life through Snowball Earth is not just a scientific story. It is a reminder of the tenacity written into existence itself. that life, however small, is a force that resists silence, that persists even in the most unlikely corners, that waits for the right moment to bloom. As you breathe softly now, perhaps with your eyes drifting heavier, you can let this story carry you. Let it remind you that survival can be quiet, hidden, patient, and that sometimes the hardest seasons give way to the brightest springs. And as our story drifts onward, the next question rises gently, like sunlight returning after a long winter. What happened when the ice finally melted? What transformations swept the planet? What landscapes emerged from beneath the frost? In our next journey, we will explore the Great Thaw, the moment when Earth awakened from its icy sleep and life was forever changed. Have you ever wondered what happens after a great silence ends, when the stillness is broken, when the ice that has pressed down for millions of years begins to crack and roar, when the frozen grip loosens and the world awakens again? What kind of landscapes emerge? What kind of skies? What kind of oceans? Imagine the Earth, sealed in ice for millions upon millions of years. Now imagine that ice beginning to melt, not in a gentle trickle, but in cataclysmic floods. The air thick with carbon dioxide, trapped and building all those years, turns the atmosphere into a sweltering blanket. From one extreme of cold, the Earth swings to another extreme. Heat rising, waters rushing, a world suddenly alive with storm and flood. Picture yourself standing at the edge of one of these ancient continents. The ground beneath you trembles as glaciers collapse, enormous rivers of meltwater tearing across the land, carving valleys, dragging stones, flooding plains. The sea levels rise rapidly, swallowing shorelines, reshaping coasts. What had been silence becomes thunder. What had been stillness becomes chaos. Scientists believe that after Snowball Earth, the atmosphere may have become almost unbearably hot. Carbon dioxide levels, built up from relentless volcanic eruptions during the freeze, had nowhere to go. With the oceans frozen, they could not absorb it. So when the thaw came, it came into an atmosphere tens of times richer in greenhouse gases than today. The heat was extraordinary, the kind of heat that would have boiled away shallow waters, turning landscapes into steaming basins. And then came the rains. Imagine the thick, heavy clouds forming, the skies darkening, lightning flashing across the sky. Rain fell for centuries, for millennia, torrents of water cascading across continents, weathering the mountains, dissolving minerals, pouring nutrients into the reborn oceans. Did you know that this rain may have delivered the very spark that fueled an explosion of life? As the torrents wore down rocks, they released phosphates and other minerals into the seas. 4 tiny organisms waiting in the shadows. This was like an endless banquet. The oceans, once starved, became rich with food and life. Patient and enduring, seized the chance. The aftermath of Snowball Earth was a world of strange extremes. One moment glaciers, the next steaming heat, then endless rains. It was chaotic, destructive, but also fertile. It prepared the stage for life to bloom in ways it never had before. There is evidence for this written in the rocks. Layers of carbonates, pale stones mark the sudden switch from icy deposits to warm seas. These stones are like a line drawn across time, the moment where silence ended and abundance began. But here is where the suspense lingers. What did life make of this new world? How did organisms adapt to this strange feast after famine? Scientists believe that it may have been here, in this post-glacial world, that multicellular life began to flourish in earnest. Before the freeze, life was simple, mostly single cells drifting in the sea. But afterward, something shifted. Complex forms began to appear, setting the stage for animals. It is tempting to imagine the first stirrings of creatures beyond the microscopic, perhaps colonies of cells that learned to cooperate, to share tasks, to specialize. The harshness of the freeze may have favored innovation, and now, with warmth and nutrients, those innovations could spread. Isn't it astonishing that out of chaos, complexity arises, that the very destruction of the thaw may have nurtured the seeds of abundance? It is almost as though the earth itself had to endure its trial, its long night, to prepare for a dawn unlike any before. Close your eyes for a moment and picture the earth, then oceans, newly thawed, shimmering under skies streaked with storm, land reshaped by flood, rivers running wild with minerals, carrying gifts to the sea, tiny organisms multiplying, drifting, forming mats and colonies, invisible to the eye but teeming, a quiet revolution beginning beneath the waves. There is comfort in this story, the idea that endings are not always final. They can be beginnings disguised. The ice seemed like silence forever. Yet beneath it, life endured, and when it ended not in ruin, but in rebirth. Did you know that some scientists believe Snowball Earth may have been the spark that made complex life possible at all? That without the freeze and the flood, perhaps animals would never have emerged. Perhaps even we would not be here. It is a breathtaking thought that your very existence may trace back to those frozen oceans and the storms that followed. It makes you think of your own life, doesn't it? Of the storms you have faced, the silences you have endured, the floods that seemed overwhelming, and yet, within them, perhaps there were seeds of change, nutrients washing into your own oceans, preparing you for a new season. So let the image stay with you. Earth wrapped in white, cracking open, roaring with meltwater, skies storming, oceans greening with life, a planet shifting from silence to song, from stillness to abundance. And as you sink deeper into rest, know that the story continues, for after the floods and storms, life began to change in ways more dramatic than ever before. The oceans became laboratories of evolution, and soon the first strange creatures would emerge, soft-bodied beings drifting across the seafloor, the ancestors of all that was to come. In our next part, we will drift gently toward those early creatures, the mysterious forms that appeared in the wake of the thaw. Life that was neither plant nor animal as we know them, but something stranger, something new, like dreams rising from the sea. They invite us to wonder what it truly means to be alive. Have you ever wondered what the very first creatures looked like? Not the fish, or the dinosaurs, or even the tiny trilobites of later seas, but the very first beings larger than a single cell, the pioneers of complexity. Have you ever imagined what forms appeared after the long sleep of Snowball Earth, as life, freed from ice and flood, began to experiment? Picture yourself standing at the shore of a shallow sea. The air is warm now, the ice is gone, the water ripples gently, sunlight piercing through to the seabed. Beneath the waves lies a world unlike anything you know, a world soft, silent, alien. The creatures here are the Ediacarans, named for the Ediacara Hills in Australia, where their fossils were first discovered. They lived around 600 to 541 million years ago, just after Snowball Earth thawed. They are strange, almost dreamlike, their bodies soft and delicate, leaving only faint impressions in the stone. They looked nothing like the animals you know today. No bones, no shells, no teeth, just soft, quilted forms spread across the seafloor. Imagine lying in bed and closing your eyes, drifting into a dream. In that dream, you see shapes like leaves, like discs, like feathery fronds swaying in the current. Some are flat and still, pressed against the sediment. Others rise like gentle fans, filtering the water for food. They do not move quickly. They do not chase or flee. They exist in a quiet, unhurried way. One of the most famous is Dickinsonia, an oval-shaped creature with rib-like segments. It could grow to over a meter long, yet had no mouth, no eyes, no stomach. It absorbed nutrients directly from the seafloor. Imagine a living carpet, slow, patient, leaving behind faint tracks in the sand. Dickinsonia is so alien that scientists long debated whether it was an animal, a fungus, or something else entirely. Only recently have chemical traces in its fossils revealed cholesterol-like molecules, suggesting it was indeed one of the earliest animals. Another form is Charnia, a frond-like being anchored to the seafloor. Picture a soft feather made of many branches, rising into the water like a plant, yet it was not a plant. It did not photosynthesize. Instead, it likely absorbed nutrients, drifting by. Silent and swaying, there were discs, too, like round impressions pressed into the sediment. Perhaps they were holdfasts anchoring fronds, or perhaps they were creatures in their own right, spreading like coins across the seafloor. Did you know that the Ediacaran creatures were the first to grow truly large for over 3 billion years? Life had been almost invisible, microscopic. You could hold the entirety of Earth's living complexity in the palm of your hand. But after Snowball Earth, these forms suddenly appeared. Some as long as your arm, some even longer than your body. It must have been astonishing if anyone had been there to see it. And yet, they remain a mystery. We do not fully know how they lived or how they reproduced. Some may have buddied off copies of themselves, like plants. Others may have scattered spores. Their fossils are like riddles pressed in stone. Questions without full answers. There is suspense in this uncertainty. These creatures existed for tens of millions of years, carpeting the seafloor, filling oceans with their strange stillness. Then, almost as suddenly as they appeared, they vanished. Their world gave way to the Cambrian explosion, when animals with shells, claws, eyes, and movement transformed the seas. Were the Ediacarans ancestors of modern animals, or were they a failed experiment? A side branch lost to time? No one knows for certain. Close your eyes and imagine drifting through that sea. You would not see predators darting. You would not see fish or coral. You would see a garden of soft bodies, pressed to the sand or swaying like ghostly leaves. The water would shimmer with particles of nutrients, the creatures absorbing them quietly. The silence would be profound, a silence of being rather than doing, of existing rather than chasing. It is humbling, isn't it, to think that this was the first true experiment in complex life, that Earth itself, having survived its icy silence, now painted its oceans with forms never before seen. The Ediacarans were not fast, not fierce, but they were new. They were possibility made flesh, and perhaps there is comfort in that. The idea that beginnings do not need to be loud. They can be quiet, they can be soft. They can look strange, uncertain. Even fragile beginnings can matter, for they set the stage for what comes after. Did you know that Ediacaran fossils are found on every continent? They are among the oldest records we have of multicellular life. They remind us that the Earth is vast, that time is deep, and that the line from them to us is long and winding. It is possible that without them, without their quiet persistence, the story of animals, fish, of reptiles, of mammals, of humans would never have unfolded. So as you lie here listening, breathing slowly, perhaps growing heavier with rest, imagine that world. The oceans gentle, the seafloor soft, strange beings swaying and resting. A time when complexity was just beginning, fragile but real, new but determined. The story of the Ediacarans is both mysterious and soothing. It tells us that life experiments, it tries, it changes. Some attempts endure, others vanish. But the story continues, always, and as our journey drifts onward, we leave behind those soft-bodied gardens, those first strange creatures. We turn now to the great leap that followed. For after the Ediacaran world ended, another world began, the Cambrian seas, filled with movement, eyes, shells, teeth, predators, and prey. A sudden explosion of life that would shape the Earth forever. Have you ever wondered what the world looked like the first time animals truly opened their eyes? The first time predators began to chase prey. The first time oceans became alive, not just with drifting, soft bodies, but with speed, with teeth, with the drama of survival. If you could stand at the edge of the Cambrian seas, over 540 million years ago, what would you witness? Imagine yourself by the shore of a vast, shallow sea. The sunlight glitters across the water. Warm waves ripple against your feet. Beneath the surface, life is stirring. Life that is stranger, more active, more daring than anything that came before. Close your eyes and take a deep breath. Feel the hush before the curtain rises, for here begins the Cambrian explosion. The Cambrian explosion was not an actual explosion, but it might as well have been. For nearly 4 billion years, life had been simple. Bacteria, algae, soft-bodied organisms drifting through oceans. Then, in what seems like a geological instant, perhaps 20 or 30 million years, the seas erupted with complexity, animals with shells, claws, spines, eyes, and jaws appeared. Entire ecosystems flourished, where before there had been only stillness. Picture trilobites, the armored pioneers of this new age. Their bodies segmented, covered in tough exoskeletons. Their compound eyes glittering like clusters of jewels, they scuttled across the seafloor, burrowing, scavenging, sometimes traveling in herds. They are among the most iconic creatures of this time. They left behind vast fossil beds, as if the world was once a trilobite kingdom, but they were not alone. In the shimmering Cambrian waters swam creatures of astonishing forms. Take its name, meaning strange shrimp, though it was neither shrimp nor fish, it could grow up to 2 meters long, making it the giant of its time, with large, grasping appendages and a circular mouth lined with serrated plates. It was a predator like no other before it. Imagine drifting near the seabed, the water, and then seeing this massive form glide toward you, its eyes large and complex, its body undulating gracefully, a nightmare and a marvel at once. Did you know that the Cambrian was the first time animals evolved eyes capable of true vision? Before this, organisms may have sensed light and dark. But now compound eyes, like those of trilobites and predators, such as Anomalocaris, opened new dimensions of awareness. For the first time, the sea was not only felt, but seen, and with sight came pursuit, with pursuit came escape. With escape came speed, armor, strategies of survival. A new world of interaction was born. The Cambrian explosion also gave us Opobenia, one of the strangest creatures in Earth's history. Imagine a small, soft-bodied animal with 5 eyes perched on stalks, and at its front, a long, flexible trunk ending in a claw. It looked like something born from a dream, or perhaps a gentle nightmare. It may have used its trunk to probe the seafloor, snatching food and drawing it to its mouth. Scientists who first reconstructed Opobenia found it so strange that when it was unveiled at a conference, the audience reportedly laughed, not out of mockery, but in disbelief at how alien life once was. And then there was Hallucigenia, a creature so bizarre that for decades scientists mounted its fossils upside down. Imagine a tiny worm-like body bristling with spines on one side and soft, wiggling legs on the other. For years, researchers thought the spines were legs and the legs were tentacles. Only later did they realize they had been seeing it backwards. Even its name, Hallucigenia, comes from its hallucinatory strangeness. Think about that for a moment as you lie here in the quiet of the night. Picture seas filled with creatures that seem born of dreams, or perhaps of the subconscious, shapes and forms we might invent in imagination. Yet they were real, swimming, crawling, burrowing, feeding, billions of years before us. But why did this sudden burst happen? Why, after billions of years of relative simplicity, did life suddenly diversify so rapidly? Some scientists believe the oxygen levels in the oceans rose, giving energy for larger, more active bodies. Others think the melting of Snowball Earth created new habitats, fresh shorelines, and nutrient-rich seas that fueled innovation. And yet others suggest it was the arms race itself. The moment predators appeared, prey were forced to adapt, to harden, to grow faster, smarter, more aware. It was a spiral of escalation. Predator shaping prey, prey shaping predator. An endless dance of survival. In this way, the Cambrian explosion was not just a blossoming of forms. It was the invention of ecological drama. The silent garden of Ediacaran life gave way to a world of pursuit, ambush, defense, and risk. The oceans became alive with story. Did you know that almost all of the major animal groups we know today trace their roots to this time? The ancestors of arthropods, mollusks, chordates began here in the Cambrian seas. It was the blueprint for the animal kingdom as we know it. Every fish, every bird, every mammal, every human carries echoes of that time in their DNA. Pause for a moment, breathe gently, and think of how deep time stretches, that your own eyes, your own heartbeat, your own hunger carry the shadows of the first eyes, the first heartbeats, the first hungers of the Cambrian seas. We are linked, thread by thread, to trilobites, to predators. Like the poetic mystery is this: life did not need to become complex. It could have remained simple, endlessly drifting, quiet, invisible. Yet something about Earth, about its cycles of ice and fire, silence and storm, urged it toward greater variety, greater depth, greater awareness. From soft-bodied carpets to armored swimmers, from still fronds to keen-eyed hunters, it unfolded as though driven by curiosity itself. And perhaps that is why the Cambrian explosion captures our imagination so deeply. It is a reminder that sudden transformations are possible, that the world can seem quiet, still, predictably, and then, in what feels like a blink, everything changes. A new chapter opens. A new kind of story begins as you drift deeper into rest. Let your mind wander through those ancient seas. Watch trilobites scuttle across the sand, their compound eyes glimmering like tiny lanterns. Watch hallucigenia shuffle awkwardly across the sediment, its spines glistening. Watch Anomalocaris glide with silent grace, hunting in the blue-green light. You are safe here, just a visitor, floating through the past. And now, gently, we drift forward again. Leaving the Cambrian seas behind, the world will change once more. The continents will shift, the oceans will swell. Life will face challenges and extinctions, but also opportunities to grow, to adapt, to become ever more complex as we turn the page. We carry with us the image of those first eyes, those first predators, those first bursts of diversity. For, in many ways, this is where the true story of animals begins. And in the chapters ahead, we will see how that story twists, deepens, and reaches toward the life we know today. Have you ever wondered what it would feel like to stand on a world where the very ground beneath your feet was in motion? Not in the way you might feel during an earthquake, but in the slow, grand way continents drift across oceans, colliding, breaking, and reforming. If Earth seems stable to us today, imagine a planet where whole landmasses constantly shifted position, creating vast new landscapes. Close your eyes and picture it. The seas of the Cambrian are alive with strange new animals. But above those waters, the continents are not as we know them. They are smaller, scattered, drifting like rafts, sometimes colliding, sometimes separating. The Earth itself is restless. Around 600 to 500 million years ago, the planet's surface was divided into fragments of ancient crust: Laurussia, Baltica, Siberia. These names sound like spells, like places in a legend, and in a way, they are. They were the giant puzzle pieces that would eventually come together to form the supercontinents of Earth's history. One of the most important of these was Gondwana. Imagine a landmass so vast it stretched from the South Pole almost to the equator. Gondwana included what we now call South America, Africa, Antarctica, Australia, India, and Arabia. At that time, it was largely barren, for land plants had not yet evolved. The continents were rocky deserts, swept by winds, their edges lapped by shallow seas, teeming with life. Did you know that Earth's surface has gone through cycles of supercontinents for billions of years? First, there was Colombia, then Rodinia, later Gondwana, Pangaea, and others. The process is called the supercontinent cycle. It is like the heartbeat of the planet, slow but constant. Each cycle takes hundreds of millions of years, with continents gathering together into a single giant landmass, then breaking apart and drifting again during the Cambrian. The Earth was in one of those gathering phases. Gondwana dominated the south, while Laurentia, the ancient heart of North America, floated nearer the equator. Baltica and Siberia wandered like islands across the seas. The arrangement of these continents controlled everything: the shape of oceans, the flow of currents, the distribution of nutrients, even the course of evolution itself. Imagine lying on the shore of Gondwana. The land is empty, no trees, no grass, not even moss, just bare rock and sand stretching under the sun. Perhaps thin microbial mats cling to moist edges, but nothing higher. The real life is still in the water, where trilobites and anomalocarids patrol the shallows. Yet even in this emptiness, the stage is being set for transformation. For one day, plants will rise here, forests will spread, animals will walk across this barren expanse. The continents are waiting, preparing, but there is suspense in this waiting. For the movement of continents is not gentle. When they collide, mountains rise. Chains taller than the Himalayas of today may have once formed and eroded away. When they separate, oceans are born, wide and deep, filled with new opportunities for life. The continents are restless storytellers, always rewriting the script. Did you know that the shifting of continents also changed the climate? The position of land at the poles or the equator determined whether ice sheets would grow or whether warm, shallow seas would dominate. These shallow seas, in particular, were vital. They flooded the edges of continents, creating vast environments rich with sunlight and nutrients, perfect nurseries for early animal life. Many of the great Cambrian fossil beds we know today, like the Burgess Shale in Canada or Chengjiang in China, existed because of these shallow, nutrient-rich margins, born of drifting continents. And there is another mystery. Some scientists believe that the movement of continents may have stirred the oceans in ways that released oxygen, fueling the Cambrian explosion. When continents rift apart, volcanic activity increases. Nutrients are delivered into the seas, currents mix more deeply, life responds. It is as though the earth itself breathes with the movement of its plates. Close your eyes now and picture Earth from space during this time. No green continents, no forests, just vast, bare landmasses of stone and sand, edged with turquoise seas. Around them the waters swirl, filled with trilobites and strange forms. The continents drift slowly, patiently, over millions of years. And though the land is silent, barren, empty, it holds potential. It is the quiet stage, awaiting its actors. There is something comforting about this, isn't there? The idea that the earth is always changing, that what seems fixed is not fixed at all. Mountains rise and fall, oceans open and close, continents gather, separate, and gather again. The world itself is a dreamer, shifting, restless, always becoming. And perhaps you feel a reflection of that in your own life. Times when things seem still, barren, waiting, only to realize later that beneath the surface, something was shifting, Something was preparing the way for change. Just as the continents prepared the way for forests, for rivers, for animals, for us. Did you know that scientists can actually trace the positions of these ancient continents through the magnetic minerals in rocks? As molten rock cools, iron-bearing minerals align themselves with Earth's magnetic field, locking in a record of where the continent was at that time. It is as if the rocks themselves remember each grain of sand a compass, each mountain a memory. Through these records, we can reconstruct maps of worlds that no human eye ever saw. Breathe deeply now, and let yourself imagine lying on Gondwana's empty plains, the wind sweeping across bare stone, the ocean calling nearby. The land may seem quiet, but in truth it is alive in its bones, its plates shifting, colliding, pulling apart. The earth beneath your body is not still. It is carrying you slowly, invisibly, across deep time. And so, in this chapter, the continents are the hidden actors. They do not shimmer like trilobites or swim like an otter, but they are no less important. They shape the seas, the climates, the oxygen, the future. Without them, the story of life would have been entirely different. And as we drift forward, we leave these barren shores behind. Soon the land will not remain empty. Soon plants will creep from the water. Forests will rise. Rivers will carve the land. And with them, animals will follow, exploring, adapting, claiming new worlds. The continents will no longer be silent. They will become alive. For now, rest in the quiet, in the vast, in the patient drift of Gondwana and Laurentia. They remind us that transformation takes time, that what seems barren is only waiting for the right moment. And that moment will come again and again. As the story of Earth unfolds, have you ever wondered what it must have been like to see the very first green upon the earth, to stand on a world of bare stone, wind-swept deserts, and lifeless coasts, and then, after ages of silence, notice the tiniest shimmer of moss, the faintest carpet of green, life daring to climb out of the water and embrace the land. Close your eyes and imagine it. You are standing on the barren shore of Gondwana. The ocean glitters at your side, filled with trilobites and strange Cambrian swimmers. But the land is still empty, silent, without trees, without birdsong, without a single blade of grass. The wind howls across rocks. Dust swirls in dry gusts for millions of years. The continents have been nothing but stone and sand. Yet now, something new begins. It starts small, so small you might not even notice. In the shallow tide pools, thin green films of algae cling to the rocks. These are the ancestors of plants, tiny pioneers that once floated in the oceans. Now, wave by wave, they creep onto the shore, spreading their delicate mats where water still lingers. They are fragile, vulnerable, but they are determined. Did you know that the first true land plants appeared around 470 million years ago? Long after Snowball Earth, but still unimaginably ancient. They were not tall trees or flowering plants, but simple mosses and liverworts, soft green carpets hugging the ground. They had no roots, no wood, no flowers, just delicate tissues that drank in moisture. Imagine a rocky surface suddenly softened by a green veil. Tiny yet revolutionary, these first plants faced enormous challenges. Water had always surrounded them in the seas, but on land, the air was dry to survive. They had to invent new strategies. They developed waxy coatings to keep from drying out. They learned to spread spores carried by the wind, and eventually, they grew tiny structures to draw water from the soil. The inventions were humble at first, but they were the keys that would one day unlock forests. Pause for a moment and breathe. Think about how fragile beginnings often are. How something as small as a patch of moss can set into motion a chain of events that will transform an entire planet. These early plants did not know that one day their descendants would become towering trees, jungles, fields of wheat, or the food we eat each day. But their courage to reach onto land began it all. As time passed, plants grew bolder. They developed vascular tissues, tiny internal tubes that let them carry water upward. This was a quiet revolution. It meant they could grow taller, stronger. It meant they were no longer confined to damp edges, but could spread farther inland. Before long, small fern-like plants appeared, rising a few inches above the ground, catching sunlight, casting shadows for the first time in Earth's history. Did you know that before plants spread across the continents, the world's atmosphere had less oxygen, and the climate was harsher? Plants began to change that. As they absorbed carbon dioxide and released oxygen, they reshaped the air itself, breathing life into the skies. Every breath you take tonight carries the gift of those early green pioneers. But the greening of the continents was not without suspense. For once plants spread inland, they began to weather rocks. Their roots split stone, drawing out minerals, and when rains came, those minerals washed into rivers and oceans, fueling blooms of algae. Sometimes this brought abundance, but at other times it triggered crises, oxygen surges, and extinctions. Life was not only adapting to land, it was altering the entire planet. Imagine walking across Gondwana now, millions of years after the first mosses crept onto stone. The land is no longer silent. Fern-like plants rise in clusters, mosses blanket the ground, spores drift like invisible dust on the wind. It is still quiet compared to the forests, you know. There are no insects buzzing, no birds flying. But there is life where once there was none. The continents are waking. There is a strange beauty in this awakening. To think of Earth painting itself green for the first time. After billions of years of gray stone and blue seas. To think of delicate mosses and tiny ferns as the first artists of land, laying a foundation for everything to come. Without them, there would be no forests, no meadows, no crops, no gardens. Without them, animals could never have followed, for there would be no food, no shelter, and soon, animals would indeed follow. Insects, amphibians, reptiles, all would one day walk across this green stage, drawn by the plant's invitation. But for now, it is enough to rest in the image of a barren world becoming softened, transformed, nourished by life's slow persistence. Did you know that some of the oldest plant fossils are found in places like Wales and Argentina? Tiny impressions of spore-bearing structures. These fossils are so small you could hold them in your palm, yet they represent the birth of forests. They are the signatures of the first brave steps onto land, etched into stone for hundreds of millions of years. Breathe slowly, deeply. Let yourself feel the comfort of this transformation. The continents were no longer lifeless. They had begun to breathe, to soften, to host something new. There is wonder in beginnings, but also peace, for change comes not all at once, but step by patient step, green patch by green patch. And so we drift from the seas to the land, from trilobites to mosses, from stone to green. Life is no longer confined. It has broken free of the waves and set down roots. The world is becoming richer, more colorful, more alive. As we move forward, we will see what happens next. Animals will not stay in the oceans forever. They will follow the plants onto land, crawling, walking, breathing air. A new chapter is waiting. But for tonight, let us linger here on the soft green edges, watching the first plants shimmer in the sunlight, hearing the silence of a world just beginning to awaken. Have you ever wondered what it must have felt like for the very first creature to drag itself onto land? To leave behind the familiar waters where life had always lived, and venture onto a world that was silent, strange, and filled with empty space. Imagine that moment, the first cautious crawl, the first breath of open air, the first footprint pressed into ancient sand. Picture yourself lying at the edge of a vast Devonian sea. The water glitters under the sun. Behind you stretches the land, no forests yet, but carpets of moss, small ferns, patches of green spreading inland. Ahead of you, the ocean is alive with trilobites, armored fish, and the drifting shadows of early predators. But now, something new is stirring at the shoreline. For hundreds of millions of years, animals had thrived only in the seas. Shellfish, trilobites, soft-bodied worms, and predators like Anomalocaris had lived in worlds of salt water. But as plants crept onto the land, they created new opportunities. Fresh water pooled in streams and ponds. Insects and millipede-like creatures followed to feed on plants. And in time, the fish too began to explore. Did you know that the first animals to crawl onto land were not reptiles, not dinosaurs, but arthropods, relatives of insects, crabs, and spiders? Over 400 million years ago, creatures like millipedes, scorpions, and centipede-like giants became the first true land dwellers. Some fossils show millipedes more than 6 feet long, crawling slowly across the barren ground. Imagine walking beside one, its many legs rippling like waves. These early arthropods were bold pioneers, feeding on plants and detritus, helping to create the first land ecosystems. They were soon joined by other adventurous forms, including primitive arachnids, ancient cousins of today's spiders. Their world was silent except for the whisper of wind, no birdsong, no buzzing. Only the sound of countless tiny legs moving over moss and rock. But the greater leap came when fish began to evolve limbs. The oceans of the Devonian were filled with armored fishes and early sharks. Yet, among them, some developed lungs in addition to gills, allowing them to gulp air when shallow ponds dried. These creatures could survive. They had fleshy fins, strong enough to push against the mud. In time, those fins became legs. One of the most famous is a transitional creature that lived about 375 million years ago. It looked like a fish, with scales and fins. Yet its fins had bones inside, more like a wrist than a fin. It had a neck, something fish never had, allowing it to lift its head and look around. Imagine Tiktaalik resting at the edge of a pond, propping itself on its strong fins, peering out onto the green shore. It was neither fully fish nor fully amphibian, but something in between. And then came the first true amphibians. Descendants of these adventurous fish, they crawled out of the water on 4 sturdy legs, their lungs breathing air, their skins moist. They still needed to return to water to lay eggs, but they were the first vertebrates to walk on land. Imagine standing in a Devonian swamp, ferns rising around you, dragonfly-like insects buzzing overhead, and at your feet a strange amphibian crawls past, half fish, half salamander, the first explorer of a new world. Did you know that these first steps onto land were as revolutionary as the Cambrian explosion? For billions of years, life had been confined to the seas. Now, for the first time, animals claimed the continents. From this daring leap would come reptiles, dinosaurs, mammals, and eventually us. Every step you take today echoes that ancient moment when a fish with strong fins first hauled itself onto shore. The suspense of this time is almost tangible. Imagine watching from the shadows as the first amphibians crawl out, their movements awkward, their bodies heavy in gravity. They are vulnerable here, far from the safety of water. The air is dry, the sun fierce. Predators still lurk in the ponds, yet step by step they persist. They test the unknown, and in doing so, they change the destiny of the earth. Breathe deeply now and let yourself drift into that ancient silence. The world is quiet except for the rustle of ferns and the slow, deliberate crawl of creatures learning to walk. No birds sing, no mammals stir, no human footsteps fall. Only these pioneers, soft and cautious, pressing the first trails into the land. There is a poetic comfort in this, for we, too, are creatures who step into the unknown, sometimes awkwardly, sometimes with fear, yet always moving forward, always daring. The story of those first amphibians is not only about biology, it is about courage, about venturing where no life had gone before. Did you know that scientists have found fossilized trackways footprints pressed into ancient mud that are older than the first known amphibian skeletons? These ghostly trails show that some animals had already been exploring land long before their bodies were preserved in stone. It is as if the earth itself remembers their footsteps. Long after the creatures themselves vanished, as the Devonian period unfolded, the land became richer, plants grew taller, forming the first forests. Insects flourished, and amphibians multiplied. The continents were no longer barren. They were alive with crawling, hopping, slithering forms. The seas still teemed with fish, but the future was shifting upward, onto the dry land. And so, as you lie here, drifting toward rest, think of that first step, that first awkward push of fin against mud, that first breath of air, that first footprint pressed into sand. It was small at the time, unnoticed by the silent continents, but it was the beginning of everything. The beginning of frogs and lizards, of birds and mammals, of footsteps and voices, of your own breath. Tonight, the leap from sea to land was not just the story of animals. It was the story of possibility, of risk, of daring to try. And from that daring, all of us have come. Now, gently, we turn the page once more. The amphibians will thrive, but they will also give rise to something new. creatures that no longer depend on the water, that can roam freely across deserts and forests, laying eggs in the sand instead of ponds. Reptiles, the next great adventurers, are waiting in the wings. Have you ever wondered what it must have felt like to be the very first creature that could truly call the land its permanent home? To never have to crawl back into the water to lay eggs, to live under the open sky without fear of drying out. Imagine stepping into a new world of endless possibilities, a world where no predator yet hunted you from above, and no giant yet ruled the ground. Picture yourself standing in a lush Devonian swamp. The air is humid, thick with the scent of wet earth and greenery. Towering ferns sway gently, while primitive trees stretch toward the sky. Not yet the massive forests we know today, but the beginning of something greater. The buzzing of dragonflies, with wings wider than your hand, fills the still air. Amphibians croak softly in the shallows. Yet something new is stirring, a creature unlike any before, a creature destined to shape the future of life on Earth. You see, amphibians were pioneers, but they were still tethered to the water. They laid eggs in ponds and streams, their soft skins drying easily in the sun. But then, a remarkable innovation appeared, something so small, yet so powerful: the amniotic egg. An egg with a protective shell, filled with fluid and nutrients. It could be laid safely on land without drying out. This single adaptation freed life from its bond to the water. From this innovation emerged the first reptiles, their bodies scaled, their skin tougher than their amphibian cousins. They could wander further, climb higher, endure harsher environments. Imagine seeing one, a lizard-like creature no bigger than your hand, scurrying across the mossy ground, its egg safely hidden beneath a fern, not in a pond, but in the earth itself for the first time. Animals had broken free from water's chain. Did you know that some of the earliest reptile fossils, like Hylinos, date back more than 310 million years? This small, lizard-like animal lived in hollow logs within dense swamp forests. Its discovery is a reminder that even the tiniest creatures can leave the biggest marks on history. For from these humble beginnings came the great reptiles that would one day dominate the earth. As reptiles spread, so too did the forests. During the Carboniferous period, around 300 million years ago, the land was covered in immense, swampy jungles. Towering trees like lycophytes and horsetails rose as high as 10-story buildings. Their trunks were thick, their roots shallow. They grew in dense groves, their canopies darkening the forest floor. Beneath them lay endless ferns, mosses, and tangled roots. The air was rich with oxygens, so much that insects and arthropods grew to astonishing sizes. Dragonflies, with wingspans wider than a hawk's, millipedes longer than a car, and scorpions as big as dogs. Can you imagine walking through such a forest? The ground soft with rotting vegetation, the air heavy and damp. Shadows of enormous dragonflies flicker overhead. A giant millipede curls across your path, its legs clicking softly against the ground. Every breath you take is filled with oxygen thick enough to make fire burn brighter and hotter than today. It was a world both beautiful and terrifying. These great forests transformed the earth in another way. As plants grew and died in massive quantities, their remains sank into swampy waters, where they didn't fully decay. Layer upon layer of plant matter built up over millions of years. Pressure and heat transformed this organic mass into coal. That's right, the forests of the Carboniferous created the coal beds that humans would one day mine and burn, fueling our industrial age. When you see coal today, you are holding the compressed breath of ancient forests. The suspense of this age comes not only from the towering creatures, but from the silent changes building beneath. As reptiles multiplied, they split into two great lineages. One would eventually give rise to mammals, and the other to the mighty dinosaurs. But at this stage, neither path was certain. Imagine the quiet tension of a world on the brink of something vast. Every small reptile hiding in hollow logs, every egg tucked beneath damp soil, carried the possibility of a future yet unwritten. Toward them, a rock 6 miles wide, traveling faster than sound, carrying the weight of destiny. The poetic reflection here is sobering, for the Cretaceous is both a story of triumph and of fragility. Life had never been so diverse, so colorful, so abundant, and yet, in the blink of a cosmic eye, it would all change. The ground-shaking footsteps of T-Rex, the graceful flight of Pteranodon, the silent glide of Mosasaurus, of it would vanish, leaving only fossils and echoes. Imagine yourself lying in a Cretaceous meadow as the sun sets. The air is golden, shimmering over the fields of flowers. In the distance, a herd of Triceratops moves slowly, their horns catching the light. Overhead, birds swoop and call, filling the sky with sound. You feel the peace of this moment, the fullness of life at its peak, and yet, somewhere deep in the silence, there is an unease. The story is not finished. The suspense lingers. And so, as we leave the Cretaceous for now, breathe deeply. Let the colors of flowers, the shadows of giants, the whispers of wings settle in your mind. The final empire of the dinosaurs is a reminder that even the greatest reigns are temporary. But within their rise and fall, the seeds of the future are planted. For when the dinosaurs fall, something new will rise. Something small, warm-blooded, and destined to inherit the earth. The age of dinosaurs is nearing its end, but the age of mammals, and eventually the age of us, is waiting just beyond the horizon. Have you ever wondered what it feels like to live on the very last day of an empire? Not just a kingdom or a dynasty, but an entire world order. Imagine waking up in the dawn of a day that begins like any other. A day full of sunlight, birdsong, and the rumble of giants walking across the land. And yet, unbeknownst to all who breathe, that day will end with fire, darkness, and the end of everything familiar. Picture yourself standing in the lush meadows of late Cretaceous Earth. The sky is vast and blue, filled with the soaring silhouettes of the air is warm, fragrant with the scent of flowering plants. In the distance, a herd of Triceratops grazes lazily, while duck-billed hadrosaurs chatter in low tones. Predators stalk silently in the forests, unseen but always present, and overhead, the golden sun spills across the land as if nothing could ever disrupt this eternal cycle of life. But far above, beyond the reach of clouds, beyond even the blue of the atmosphere, a rock is racing toward Earth. It is 6 miles wide, a mountain of stone and metal, moving faster than sound, faster than comprehension. It has traveled millions of years through space, silent and unseen until now, and it is aimed with merciless precision at our fragile blue planet. Scientists tell us this asteroid struck near what is now the Yucatan Peninsula in Mexico, creating the Chicxulub crater, over 180 kilometers wide. But before impact, before fire, before shock, there was suspense, for in those final moments, the Earth looked calm, the dinosaurs grazed, the oceans lapped gently at the shores, the birds sang in the trees. All was peace. Then it began. First came the light, a blazing streak across the sky, brighter than 1,000 suns. Imagine standing on the plains as the heavens suddenly tear open. A burning star descends, trailing fire, casting shadows sharper than any midday sun. The animals look up, confused. Herds stir nervously. Predators pause mid-hunt. Birds scatter in clouds. The ground vibrates with anticipation. And then, in a moment of unbearable suspense, silence. The rock strikes Earth, releasing energy greater than billions of atomic bombs. A shockwave bursts outward at supersonic speed, flattening everything within hundreds of miles. Forests vanish in an instant. Oceans leap from their basins. Firestorms ignite across the land. The sky itself seems to shatter. Imagine the terror of that moment. A herd of hadrosaurs running, only to be engulfed in a wall of fire. Raptors scattering into forests that are already burning. Tyrannosaurus rex roaring as the ground trembles beneath it. Rivers boil, winds scream. The world as it was ends in a single apocalyptic heartbeat. But the true horror was only beginning, for after the fire came the darkness. Dust, ash, and vapor rose into the atmosphere, so thick that sunlight was blocked. Days turned into twilight, twilight into blackness. The temperature plunged, plants withered, photosynthesis stopped, herbivores starved, predators followed. The mighty dinosaurs, rulers of Earth for over 150 million years, fell silent. And yet, in this abyss of despair, suspense takes a gentler form, for not all life perished. Small creatures, often overlooked, endured. Mammals, once tiny and hiding in shadows, found food in seeds, insects, and roots. Crocodiles waited patiently in rivers. Birds, descendants of small feathered dinosaurs, found ways to adapt. Life bent, but it did not break. Did you know that the asteroid's impact created tsunamis taller than skyscrapers? That they raced across oceans, flooding coastlines continents away? Did you know that fragments of molten rock rained back from the sky like fiery hail, scorching the Earth for miles? Scientists have found tiny glassy spheres stacked tight scattered around the world. Relics of that cosmic moment. Every pebble is a whisper from that day. Frozen in time, the poetic reflection here is profound. The end of the dinosaurs was not just an ending, but a transformation from their fall. Mammals rose from darkness. New forms of life emerged. It is a reminder that endings are never truly final. They are thresholds, doors closing, so others may open. Close your eyes and imagine yourself standing at the edge of a silent landscape days after the impact. The air is heavy with ash. The sun is only a pale ghost behind a blackened veil. You walk through a forest of charred stumps. The silence pressing against your ears. Here and there, the faint rustle of a small mammal, the flutter of a bird. Life persists, fragile but determined. And now imagine the suspense of time itself. Millions of years passing in silence, the earth slowly healing, green returning to gray landscapes, forests sprouting anew, oceans calming, and in the shadows, tiny mammals growing bolder, multiplying, spreading. The world is no longer ruled by dinosaurs. The throne is empty, waiting. The smooth transition is this. As we close the chapter of the dinosaurs' reign, we open the chapter of something new. The fire from the sky ended one empire, but it cleared the stage for another, the story of mammals, the story that will eventually lead to us. And so, as you breathe deeply and drift deeper into rest, remember, the greatest endings always carry within them the seeds of beginnings. Did you know that in these forests, fire played a dramatic role? Because the air was so oxygen-rich, lightning strikes could ignite massive wildfires. Flames roared through the dense swamp, sending plumes of black smoke into the sky. Fossilized charcoal from this era reveals how frequent and devastating these fires were, and yet life persisted. The forests regrew, the reptiles survived. The earth continued to turn as night falls in this ancient forest. Imagine lying in the undergrowth, looking up at the towering lycophytes. Their branches stretch into the mist. The air is alive with the hum of insects, the rustle of small reptiles darting between roots. The silence is broken only by the distant croak of an amphibian or the hiss of something sliding through the ferns. This is a world where giants are yet to come, but the stage is already being built. There is a deep poetry in this time. For the forests themselves became the lungs of the earth, breathing in carbon dioxide, exhaling oxygen, laying down the foundations for future life. The reptiles, small and fragile at first, were like sparks in the dark, tiny flames that would one day blaze into empires of dinosaurs and beyond. Everything that walked, crawled, or breathed after this age owed its existence to those forests and those small, scaly pioneers. As you drift deeper into this story, let yourself rest in the idea of transformation, of small beginnings leading to vast destinies. The first reptiles were not mighty, they were not terrifying, they were delicate creatures scurrying in shadows. Yet their innovation, the egg that held life safe on land, was a key that unlocked the future. Without it, there would have been no reptiles, no dinosaurs, no mammals, no humans. And so, with gentle suspense, we leave this chapter. The forests will grow denser, the reptiles will grow bolder, the earth will soon face fire, ice, and upheaval. But through it all, life continues, pressing forward into the unknown. Now, breathe deeply. Let the hum of those ancient forests fill your imagination, and prepare yourself for the next great turning of the story. For soon, we enter an age of dominance, an age when reptiles no longer skulk in shadows, but rise to rule the world. Have you ever wondered what it must have been like to witness the first dinosaurs? To stand on the edge of a primordial plain, the air thick with the scent of ferns and volcanic ash, and hear the distant rumble of something enormous moving through the mist. The ground trembles faintly, the plants shiver, and before you, a creature unlike any the earth has ever seen emerges from the shadows. Close your eyes for a moment and picture this scene. The world is no longer the lush, swampy forest of the Carboniferous. Much has changed. The continents have collided, forming the vast supercontinent of Pangaea, stretching nearly pole to pole across its endless deserts. Mountains rise in jagged ranges, rivers cut across dry plains, and forests of conifers and cycads grow where the climate allows. The air is drier now, the swamps receding. The age of giant insects has passed, and into this harsher world stepped the true rulers of the land dinosaurs. But their rise was not instant. It began slowly with survivors. For before the dinosaurs came the Permian, a time of abundance, but also of catastrophe. Imagine a world dominated by strange reptilian creatures, sail-backed, tusked dicynodonts, and sprawling amphibians like They filled the swamps and plains, ruling long before the first dinosaur appeared. And then the earth trembled with disaster. Around 252 million years ago, the greatest extinction in Earth's history struck, the Permian extinction. Over 90% of all species vanished. Entire forests burned, oceans grew stagnant, skies darkened with volcanic ash. The world nearly went silent, and yet life persisted. From the ashes of this devastation rose new survivors, fleet-footed reptiles, clever and adaptable. They were the ancestors of dinosaurs. Their story is one of resilience, of rising after the darkest night. The suspense here is almost unbearable. Imagine walking across the desolate Pangaean desert. Few plants, few animals, only silence broken by the whisper of wind. But hidden in the shadows, tiny creatures scurry. They are fragile now, but in time they will shake the earth. Did you know that the very first true dinosaurs were not giants? They were small, two-legged, almost delicate in form. One of the earliest, Eoraptor, lived around 231 million years ago. It was about the size of a dog, lightweight, agile, darting among ferns and shrubs, hunting insects and small prey. To us, it might not seem impressive, but Eoraptor and its kin carried the blueprint of what would become the most iconic animals to ever walk the earth. As the Triassic period unfolded, dinosaurs diversified. Some became swift hunters, like Herrerasaurus, stalking prey with sharp teeth and strong jaws. Others began to experiment with plant-eating. Their limbs grew stronger, their tails longer, their necks stretched out. Imagine standing at the edge of a Triassic floodplain, where rivers carved through dry soil. Herds of early dinosaurs wander by, not yet titanic, but already different, already preparing for greatness. The world itself added to the suspense. Pangaea was vast, with climates that swung between scorching deserts and monsoon-flooded lowlands. Volcanic eruptions darkened skies, and earthquakes split the land. In this unstable world, only the most adaptable survived. That is why dinosaurs triumph. They were fast, efficient, and resourceful. They laid eggs with protective shells, just as their reptile ancestors had. But they took things further. Their bodies grew lighter, their skeletons strong yet hollow. They were built for endurance, built for dominance. And then, around 201 million years ago, another great extinction struck, wiping out many of their rivals. The stage was cleared, and the dinosaurs stepped into the spotlight. Can you feel the tension of this turning point? The forests are alive with the calls of strange reptiles. The rivers ripple with crocodile-like creatures, but suddenly all of them begin to vanish. The earth trembles once more, and when the dust clears, dinosaurs remain. They rise, filling every niche, every corner of the land. From small hunters to massive plant-eaters, their age has begun. Did you know that some early dinosaurs were feathered long before birds appeared? Fossils reveal delicate impressions of primitive feathers, used not for flight, but for warmth or display. Imagine a dawnlit plain, a small raptor-like dinosaur stretching its feathered arms, the light glinting on colorful plumes. It is not a bird, not yet, but it is a glimpse of what the future holds. The poetic reflection here is profound. The dawn of the dinosaurs is not just about size or power. It is about persistence, about seizing opportunity in the face of catastrophe. Every giant that came after the towering the fierce Tyrannosaurus, the swift Velociraptor, began as something small, fragile, and almost invisible. Life has always whispered before it roared. Imagine yourself lying in the shade of a Triassic tree, breathing deeply, listening to the distant calls of these first dinosaurs. The air is warm, dry, carrying the smell of dust and resin. A small herd of plant-eaters passes quietly, tails swaying, heads dipping to feed. A predator lurks in the underbrush, its yellow eyes watching, waiting. You hold your breath, unsure of what will happen. The suspense is sharp, almost alive. This is the feeling of a new age beginning. And so, as the Triassic gave way to the Jurassic, the dinosaurs were ready. They had survived extinction, drought, fire, and ash. They had evolved into forms that would soon tower over the earth. The age of dinosaurs had truly dawned, and with it, the world would never be the same. Breathe deeply now, and let the echoes of their footsteps lull you, for soon we will walk beside the giants, through forests where tree trunks reach like cathedral columns, and the ground shakes with the steps of titans. The suspense builds, for the giants are coming. Have you ever wondered what it would be like to stand beneath a creature so large that its head disappears into the clouds? To feel the ground tremble with each step it takes? To hear the slow, thunderous heartbeat of a living mountain? This is not a fantasy, it was the reality of the Jurassic period. A world where dinosaurs reached their greatest size and diversity. Picture yourself standing in a vast Jurassic Valley. The land stretches wide, filled with ferns and towering conifers. Rivers wind through open plains, and the sky glows with a warm haze. In the distance, shadows move, immense and slow. You strain your eyes, and then you see them giant sauropods, their long necks sweeping above the trees, their tails stretching behind them like living bridges. Each step sends a deep vibration through the ground, a reminder that this is their world now. The Jurassic period, lasting from about 201 to 145 million years ago, was the golden age of dinosaurs. After the uncertainties of the Triassic, the Earth had stabilized into warmer, wetter climates. Forests flourished, food was abundant, and dinosaurs took full advantage. Some grew 2 sizes beyond anything the planet had ever seen. Sauropods like Brachiosaurus, Diplodocus, and Apatosaurus became the true giants. Brachiosaurus could reach heights of 40 to 50 feet, taller than a 4-story building, its neck allowed it to browse the tops of conifers, pulling down branches that no other animal could reach. Can you imagine standing in the shadow of such a creature? Its sheer size, overwhelming, its every breath a gust of wind. And yet these giants were gentle, peaceful plant-eaters who spent their days slowly grazing. Their strength was not in aggression, but in presence. Their size alone kept them safe. But where there are giants, there must also be hunters, and in the Jurassic, the predators grew to match. Allosaurus was among the most fearsome, a swift and powerful carnivore. Imagine a pack of allosaurs stalking through the forest, their eyes glinting in the dim light, muscles rippling beneath scaly skin. They work together, circling, watching for the weak. Perhaps they target a young sauropod or a slower member of the herd. The air thickens with tension. The herd senses danger, tails whip, necks sway. The suspense builds until suddenly chaos erupts. The predators strike, the ground shakes, and life and death collide in the ancient forest. Did you know that sauropods may have defended themselves, not only with size, but with their tails? Some could whip their tails with enough speed to break the sound barrier. The crack would have echoed like thunder, startling predators and rivals alike. Imagine that sharp sound splitting the humid Jurassic air, a whip of power echoing across the valley. But not all Jurassic dinosaurs were giants or killers. Some were quick, nimble, feathered, and surprisingly bird-like. The first true birds evolved during this period. Archaeopteryx, discovered in limestone quarries in Germany, is one of the most famous fossils in the world. It had feathers, wings, and could glide or perhaps fly short distances, yet it still had teeth and a long, reptilian tail. It was both bird and dinosaur, a living bridge between two worlds. Imagine watching one flutter through the trees, its wings catching the sunlight. The Earth itself was alive with change. The supercontinent Pangaea had begun to split, carving new seas and coastlines. This separation created diverse habitat. Dinosaurs spread across them, adapting to forests, plains, deserts, and coasts. From Europe to Africa, from the Americas to Asia, the world belonged to dinosaurs. And in the seas, another spectacle unfolded. The oceans teemed with marine reptiles streamlined like dolphins, hunted schools of fish. Pliosaurs, with massive jaws, ruled as apex predators. Some grew longer than a bus. Imagine standing on a Jurassic beach, the waves crashing, and far out in the surf, the dorsal fin of an ichthyosaur slices the water. Beyond, a pliosaur surfaces, jaws wide, scattering fish like sparks in the deep blue. The oceans were no less dramatic than the land. Did you know that some Jurassic flying reptiles, the pterosaurs, had wingspans rivaling small planes? Rhamphorhynchus and Pterodactylus soared above the forests, diving for fish in rivers and lakes. Imagine lying back in the grass, watching the sky darken with their silhouettes, graceful, eerie, filling the heavens with movement. The Jurassic was not just the age of giants, it was the age of sky, sea, and land united under reptilian rule. There is a deep poetry in the Jurassic world. It is a reminder of balance, of ecosystems vast and complex. The giants grazed, the hunters stalked, the birds took wing, and the seas roared with predators. Each creature, from the smallest insect to the largest sauropod, played a part in the great orchestra of life. The suspense of survival was constant, yet the harmony endured. Now, close your eyes and imagine yourself sitting at the base of a towering conifer. The air is warm, rich with the smell of pine resin in the distance. The herd of sauropods continues to graze. Each step they take is slow, deliberate, timeless. You hear a flutter above a feathered Archaeopteryx gliding past. Behind you, the distant roar of an Allosaurus rolls through the valley. Yet you feel no fear, only wonder. You are surrounded by life at its most magnificent. As night falls in the Jurassic, the stars shine brightly above, but the land below is alive with shadows. You hear the low rumble of creatures settling, the quiet splash of a marine reptile surfacing offshore, the flap of wings in the starlit sky. The suspense is still there, for danger never truly leaves. But alongside it is beauty, power, and awe. And so, the Jurassic period teaches us something profound, that life thrives not only in small beginnings or quiet survival, but in boldness, in grandeur, in reaching upward and outward until the world itself feels transformed. The dinosaurs did not merely live, they redefined what life could be. Breathe deeply and let their footsteps echo in your mind. The age of giants has only just begun, but soon the story will shift again. For, as mighty as the Jurassic was, an even more dramatic stage awaits. The Cretaceous, the last and most spectacular act of the dinosaurs, and the age that would bring both triumph and tragedy. Have you ever wondered what it feels like to live in the very last chapter of a story? To walk through a world at its peak, full of color, sound, and life, and yet to sense, deep in your bones, that it cannot last. That is the feeling of the Cretaceous period. The dinosaurs ruled more powerfully than ever before, and yet the shadow of their end was already written in the stars. Close your eyes and picture yourself in the Cretaceous landscape. The air is warmer, the forests more diverse. Vast flowering plants now bloom across fields and riverbanks, filling the world with new colors and scents. No longer only ferns and conifers, now there are blossoms. Petals, nectar, fruits hang heavy from branches, and insects hum as they gather pollen. The world is brighter, richer, more alive than it has ever been. And through this lush abundance move the dinosaurs. Now at their most spectacular, herds of triceratops graze across open plains, their massive frilled skulls catching the sunlight. Herds of duck-billed hadrosaurs move beside them, lowing softly like ancient cattle. In the forests, armored ankylosaurs shuffle, their backs covered in plates of bone, their tails armed with heavy clubs, and high above, pteranodons soar with wings wider than a small plane, riding the coastal winds. But towering above them all is the giant of giants, one of the largest land animals to ever walk the earth. Imagine standing in the grasslands as this colossal sauropod passes by. Its legs are like tree trunks. Its shadow falls across you like a moving mountain. Its neck stretches out longer than a bus, pulling leaves from the highest branches with ease. Each step sends a tremor through the ground, reminding you that here, size is survival. Did you know that the Cretaceous also gave rise to some of the fiercest predators the world has ever known? Tyrannosaurus rex, the king of predators, appeared late in this period, with teeth the size of bananas, a bite force stronger than any land animal before or since, and a presence that could terrify anything within sight. Imagine standing in a clearing as the forest suddenly goes silent, the birds scatter, the ground shakes, and through the trees comes the shadow of T-Rex. Its massive skull swings side to side, nostrils flaring, eyes sharp and calculating. You know in that moment that you are standing before power incarnate. Yet T-Rex was not the only terror of its age. Across the seas, monsters lurked. The oceans of the Cretaceous were filled with marine reptiles, none more fearsome than the most. Imagine standing on a cliff above a Cretaceous sea. The waves below churn suddenly, and a massive reptilian head bursts from the water, jaws wide, lined with conical teeth. A mosasaurus, as long as a bus, launches itself into the air, dragging a struggling prey down into the deep. The ocean was every bit as dangerous as the land. The suspense of this world is overwhelming everywhere. Predators and prey are locked in a delicate balance. The herds must stay alert, for at any moment, a pack of raptor-like dromaeosaurs could strike, small but deadly, with sickle-shaped claws and sharp intelligence. Raptors hunted with strategy, coordinating like wolves, their calls echoing through the undergrowth, chilling, precise. Imagine lying in the grass at night, the moon bright above, and hearing the soft rustle of many feet closing in. Their glowing eyes catch the starlight, and you realize you are surrounded. But alongside this tension, there is profound beauty. The Cretaceous was the age when flowers blossomed, and with them came the buzzing of bees, pollinators that began a partnership with plants still thriving today. Birds, too, had fully taken flight, evolving from small, feathered dinosaurs into creatures that could soar across entire continents. Imagine standing in a meadow, the air filled with petals drifting like snow, while birds with colorful feathers dart overhead. Their songs carry through the forest, the very first dawn chorus of history. Did you know that during the Cretaceous, the Earth's sea levels were some of the highest in history? Shallow seas flooded much of the continents, dividing North America into two great landmasses, with a vast inland sea between them. These waters created rich habitats, teeming with life. Coral reefs flourished, ammonites swirled in great schools, and giant turtles paddled slowly through the shallows. Imagine looking out across a landscape where dinosaurs roamed the shorelines, while sea reptiles hunted just beyond the waves. Land and ocean, predator and prey, all connected, and yet, for all its brilliance, the Cretaceous carried a hidden suspense, for this was an age moving toward an end. Volcanic activity rumbled beneath the earth, climate shifted, ecosystems strained. Still, the dinosaurs thrived, unaware that far beyond the sky, a rock was hurtling too.